With respect to the examples that we have seen so far, let's make some observations. If we look at the region of convergences for the examples that we have seen so far, you may see that these region of convergences are actually having the shape of a kind of strips. The strips that are parallel to this j omega axis. You may see that all the region of convergence, you may take any example, this region of convergences are going to be kind of strips that are parallel to this j omega axis. You may see from this example, first example that we have seen, the second example that we have seen, you may see that the strips are going to be the parallel to j omega axis, just because now this might be due to the fact that the region of convergence depends on this sigma factor, that is the real part, and not the j omega or the imaginary part. Therefore, this region of convergences, this region is in fact a strip that is parallel to j omega axis. You may see that from all the examples that we have seen so far. So let's write that observation. So the first observation about the region of convergence is that the ROC, the region of convergence, consists of strips, would consist of you can say strips that are parallel to j omega axis. That's the first observation that we can make from the region of convergences that we have seen so far. The second observation that we can see is that this region of convergences, as you can see, the shape of the region of convergences, or the area, you can see that this area, let's take this example, the first example. You can see that this region of convergence does not contain any pole in that. This pole is just on the verge of this region of convergence. As you can see, this region of convergence here in this example is greater, not equals to, it is greater than -1, and the pole is located at -1. So although it is bounded by this pole here, the region of convergence itself doesn't contain any kind of pole. Here also you can see that the region of convergence does not contain any pole, and that is by the definition of the pole itself, because the pole definition says that a pole is a value of s for which this x of s turns out to be infinite, and the region of convergence itself says that they are those values of sigma for which this expression turns out to be finite, or it doesn't shoot to infinite. So both of these terms are contradictory, and therefore these poles cannot be a part of this region of convergence. So let's write that region of convergence ROC does not contain any pole, does not any pole. What about zeros? Well, region of convergence may contain zeros, but not pole, just because the pole will make the expression infinite, and that's what we don't want, because we want the expression to converge. Therefore, it may contain 0, but so may contain or may include zeros. But strictly the poles are not allowed. And that's because of the definition of this pole. Now let's make another observation. Consider this example. The example on the left, you can see that a signal e power minus tut, we have made this observation earlier also. This is a kind of right hand sided signal. That means the signal is moving towards right. You can see that here. And for such signals, the region of convergence is rightwards. Similarly, for the second example here, where the signal is leftwards, that means the signal is moving towards left, the region of convergence is towards the left. Let me write these observations here for the region of convergence here. So we have here as the region of convergence the third observation, the ROC of a right hand sided signal. So let me write that right hand sided signal is going to be rightwards. So let's take this example also, the recent example that we have seen. This signal is also moving towards right just because it is having this ut. Both of these signals, when added, it will be towards right. So for this signal also, the ROC is towards right. And if you observe it very closely, that it is towards right of the rightmost pole that is present for this expression. You can see that from this expression that we got two poles here at s equals to -2 and s equals to -4. Just because the signal was right hand sided, the ROC is towards right of rightmost pole. So let's write that. So for right hand sided signal, the ROC is going to be towards right of rightmost pole. That's interesting. Similarly, for the left hand sided signal, if instead of right hand sided, if you would have this left hand sided signal, so ROC would have been ROC of left hand side signal so it is sided is towards left. You can see that for left hand sided signal, let's take this example here. This example, the signal is leftwards, is moving towards left, so the ROC is towards left. And in fact, if there would have been multiple such poles, then it would have been towards the left of leftmost pole. So let me write that here, towards left of leftmost pole. So that is what is called as the properties of region of convergence. Now instead of this, if we have a signal that is both sided, as you can see that from here, a signal from this example, as you can see, this example is having the signal that is both sided, or two-sided we can say, then the region of convergence is a kind of strip, a strip that includes this j omega axis. So let me write that. If a signal is two-sided, so ROC of two-sided signal would consist of strip that would include you can see that from here in this example this signal is two-sided, and therefore this region of convergence includes this is a kind of strips that is again parallel to j omega axis and will consist of a strip that will include a line in this S-plane. So I'll simply write it as a strip this is unlike to the previous examples that we have seen. For the, you can see that from the left hand sided signal, as we have it here, for left hand sided signal this region of convergence is tending towards infinite. It is moving towards left, but it is tending towards infinite. For right hand side signal it is again rightwards, but again moving towards infinite. But for two-sided signals it is strictly between those two poles, and it is a kind of strip parallel to j omega axis in the S-plane. So that's what is written here. The ROC of a two-sided signal would consist of a strip in a S-plane. And for left hand right hand sided signal, those region of convergences are going to be towards infinite. So that is what is the property of region of convergence for the two-sided signals. Now what about the signal? Let's say if I am having a signal that is finite in duration, so that is neither left hand sided nor right hand sided, it is finite in duration. For such signals, so ROC of finite duration signal would be, so for such signals, just because it is finite in duration, there is no constraint of region of convergence, that signal is always going to converge. So the region of convergence for finite duration signal would be entire S-plane except possibly at say s equals to 0 or s equals to infinite. What I mean by that is, if a signal is finite in duration, then just because it is finite in duration, it doesn't have any convergence constraint. Just because it is finite in duration, the integration is going to converge. Therefore, such signals would have the region of convergence as an entire S-plane, except the possibility would be it may diverge at s equals to 0 or s equals to infinite. And we'll take one such case in the next module. See you then.